Welcome to Spring LIB.
All right, so you're given a lot of information there, and part of that is that QN and SM are perpendicular and RN and SP are perpendicular, which are already marked by, by the right angles here, okay? So that was given. Then this would mean that they're right angles as marked in the diagram because that is the definition of perpendicular. I'm using symbols for my space, but because we're given perpendicular, that's what it would mean, that we're creating right angles. We were also given that n is the midpoint of segment MP. That was a given piece of information. If n is the midpoint of NP, then that is why MN is congruent to PN. That is the definition of midpoint. To be in the midpoint means you've got congruent segments on each side. QN congruent to RN was another given piece of information. And now these triangles, MQN and RPRN, are congruent because we have corresponding congruent hypotenuse and legs in right triangles, so that's by HL. Then we would know that angle M and angle P are congruent because those are corresponding angles in those congruent triangles. That's called CPCTC. Corresponding parts of congruent triangles are congruent. Then SM would be congruent to SP. That's depending on, it varies from textbook to textbook, but what we have here is essentially a triangle with two congruent angles. That would be the converse of the isosceles triangle theorem, or just the I'm just going to say isosceles triangle theorem, because I think it can go both directions. If two sides of a triangle are congruent, that's the definition of isosceles, and if two angles are congruent, then we are isosceles. They come hand in hand. So this could be the converse. You might want to double check on that depending on the text. And so this would be the definition of isosceles. Once we've established that the sides SM and SP are congruent, that is the definition of being isosceles. And I think this is the isosceles triangle theorem. But I'm questioning this one. You need to double check that one.